Welcome back to my YouTube channel GrandpaMathematics. Today let us do some more problems on miscellaneous exercise of chapter 7. We have to evaluate this integral. Tan inverse of sin x is there, so we have to take sin x as y. So we can write this as integral 0 to pi by 2 sin x cos x tan inverse of sin x dx. Because tan inverse of sin x is there, take sin x as y. So let when x is 0, x is 0 means sin 0 0, so y is 0. When x is pi by 2, x is pi by 2, sin 90 is 1, so y is equal to 1. Therefore 1 becomes integral 0 to 1 tan inverse of sin x. So tan inverse of y sin x is y, cos x dx, cos x dx is dy. Now we can integrate this integration by parts. This cannot be integrated, so we can integrate y. So y square by 2 into tan inverse y 0 to 1 minus integral of integrated function y square by 2. If we differentiate tan inverse y, 1 by 1 plus y square dy. Now this is equal to 2 times. When you substitute y is 1 by 2, tan inverse 1 is 45 degree, pi by 4, minus, if you put y is 0, it will become 0, then this minus this half we take outside, then integral 0 to 1 y square by y square plus 1 dy. Y square plus 1 is the right, plus 1 minus 1. So y square plus 1 by y square plus 1 is 1. Then this we can write minus 1 by y square plus 1. This will become pi by 4 minus 2 into half, that becomes 1. Again integral 0 to 1, this becomes 1 dy, minus into minus plus integral 0 to 1 dy by y square plus 1. So this becomes pi by 4 minus y 0 to 1. This will be tan inverse y, again 0 to 1, if you put y is 1, it will be 45 degrees. So it will become pi by 2 minus 1. So this is the answer. This integral x is there in the numerator. X is there in the numerator. So you have to use the property 0 to a f of x dx is equal to 0 to a f of a minus x dx. This property we have to use. What will happen now? 0 to pi, we are replacing x by a minus x. X by a minus x. X by a is pi here. So pi minus x tan of pi minus x by secant of pi minus x plus tan of pi minus x dx. So this is equal to 0 to pi minus x. What is tan of 180 minus x? This will be minus tan x, because second quadrant only sine and cosecant only will have positive values. So this will be minus secant x minus again tan x dx. Take minus sign outside, so it will become 0 to pi minus x into tan x by secant x plus tan x. So we can write this as I is equal to 0 to pi tan x by secant x plus tan x dx minus 0 to pi x tan x by secant x plus tan x dx. You see now 0 to pi x tan x by secant x plus tan x dx is nothing but I only. So I am just replacing this with I. So when you take I to the left hand side, 2I is equal to 0 to pi tan x by secant x plus tan x. Since it's not possible to simplify as such, we'll write all the trigonometry tan x and secant x in terms of sin and cos. So this is equal to pi 0 to pi tan x is sin x by cos x. This is 1 by cos x sin x by cos x dx. So tan x sin x by cos x is the 1 by cos x plus sin x by cos x, that the cos x gets cancelled. We have to make the denominator as a single term. So multiplying 1 minus sin x by 1 plus sin x into 1 minus sin x is 1 minus sin square x dx. So 2I is equal to pi 0 to pi sin x minus sin square x by cos square x dx. sin x by cos x is tan x, and 1 by cos x is secant x dx, minus again pi integral 0 to pi sin square x by cos square x is tan square x. Equal to pi secant x 0 to pi minus integral 0 to pi secant square x minus 1 dx. This will be pi into secant pi minus secant 0 minus of, if we integrate secant square x, we'll get tan x. So this will be pi cos 180 is minus 1. So minus 1 minus of tan 180 is 0. So minus pi, then tan 0 0 0. So will be pi minus 2 plus pi so pi square minus 2 pi into pi minus 2. Therefore I is equal to pi by 2 into pi minus 2. So this is the answer. So in this problem, modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3 is there. We'll equate, if we equate x minus 1 to 0, we'll get the value of x is 1. Similarly, we'll get values for x is x minus 2 is equal to 0. This gives x is 2, and this gives x is equal to 3. Therefore, I is equal to integral 1 to 2. 1 to 2. In 1 to 2, if you put any value here, 1.5 minus 1 is positive value, you're getting positive value, so x minus 1. Here, if you put 1 to 2, 1.5 minus 2 is negative value is coming. So write to 2 minus x, that is minus of x minus 2, 2 minus x. If you put 1.5 here, 1.5 minus 3 is minus is coming. So put negative sign. That is 3 minus x. Minus of x minus 3 is 3 minus x. Now 1 to 4, we write only 1 to 2 plus 2 to, again 3 is there. So 2 to 3, so take 2.5. X value varies from 2 to 3, you put 2.5. 2.5 minus 1 is positive value, so write x minus 1 only. 2.5 minus 2 is positive value, so write x minus 2. 2.5 minus 3 is minus is coming, so write 3 minus x here. So we are taking positive value dx plus 3 to 4. Now take the value of 3.5. 3.5 minus 1 positive, so x minus 1. 3.5 minus 2, again positive value. Again positive value. So now we have removed the modulus. Now this is equal to integral 1 to 2 x minus x minus x. So x minus x minus x. So minus x, 2 plus 3, 5 minus 1. So dx plus x plus x minus x. So here comes 2 to 3. 2x minus x is x. Minus 3 plus 3, 0. So x only. Plus 3. Now we have to integrate and we have to substitute the upper limit and lower limit. On integrating we will get 4x minus x square by 2. Limit varies from 1 to 2 plus x square by 2. Limit varies from 2 to 3 plus 3x square by 2. 3 by 2 x square minus 6x 3 to 4. Limit varies from 3 to 4. Now substitute upper limit. 4 into 2 8 minus 2 into 2 4 by 2 2 minus of lower limit we have to substitute now. 4 into 1 4 minus 1 by 2. This plus here. Then 3 square 9 by 2 minus 2 square 4 by 2, that is 2. Then for x minus of 3 by 2, 3 into 3 9, 9 into 3 27 by 2 minus 18. 8 minus 2 6, 6 minus 4 2, 2 minus 2 0, 2 minus 4 minus 2, so 0 cancelled, will become 18. Then plus half plus 9 by 2 minus 27 by 2, 23 minus 27 by 2, 46 minus 27 by 2 is equal to 19 by 2. Answer. So we have to prove integral 1 to 3 dx by x square into x plus 1 is equal to 2 by 3 plus log of 2 by 3. So we have to use the partial fraction method. So let 1 by x square into x plus 1, this becomes a by x plus b by x square plus c by x plus 1. Multiply throughout by x square into x plus 1 we get, put x is 0, minus 1 and then plus 1 to get the values of a, b and c. So a is minus 1, b is 1 and c is 1. So we can replace a by minus 1, b by 1 and c by 1. So integral 1 to 3 dx, integral 1 to 3. So on integrating we'll get minus of log x. This will become x power minus 2, so x power minus 1 by minus 1 plus log of x plus 1, limit varies from 1 to 3. Now put x is 3. So we'll get minus log 3 minus 1 by 3 minus x is 1 by 3 plus log of 3 plus 1 4 minus of, put x is 1, minus log 1 minus 1 by 1, x is 1 by 1 plus log 2, 1 plus 1, 2. So this is log 4 minus log 3, then log 1, this becomes a 0, minus log 2, then plus 1 minus 1 by 3. Then this can be written as a log of 4 by 3 into 2 plus 2 by 3. So this is log of 2 by 3 plus 2 by 3. So we know integral 0 to 1 x e power x dx, we can integrate this by integration by parts. We can integrate e power x into second function x 0 to 1 minus integral of integrated function e power x into differentiation of x1 into dx. If you put x is 1, it will become e minus, if you put 0, 0 minus, if we integrate e power x only will come 0 to 1. So e minus of e minus e power 0 is 1. So in this integral, f of x is x power 17 cos power 4x. We'll find f of minus x. Minus x power 17 cos power 4 minus x. So this will become minus x power 17 is equal to minus f of x. Therefore, minus 1 to 1 x power 17 cos power 4x dx is equal to 0, since f of minus x is equal to minus f of x. That is, f of x is an odd function. So in this integral, let I is equal to 0 to pi by 2 sine cube x dx. So here we can write sine cube x as sine square x into sine x. Sine square x we can write in terms of cos x. That is 0 to pi by 2 sine square x is 1 minus cos square x. We different cos x minus sine x will come. So I am putting one more minus here. So sine square x minus into minus plus sine x is sine cube x dx is there. When let cos x is equal to y, this gives when x is 0, then cos 0 is 1 minus sine x dx is dy. When x is 0, y is equal to 1, cos 0 is 1. When x is pi by 2, cos pi by 2 is 0, so y is 0. Therefore 1 becomes I is equal to minus integral 1 to 0 1 minus y square dy. So this we can write as integral 0 to 1 minus y square dy. So on integrating we get y minus y cube by 3, again 0 to 1. So 1 minus 1 by 3, if we put 0, that will become 0. So it will become 2 by 3. So this is the answer, hence proved. So to integrate tan cube x, we have to see how to get the secant square x. So we can write this as tan square x into tan x, that is secant square x minus 1 into tan x dx. Secant square x minus 1 is tan square x into tan x is tan cube x. So whenever tan is coming, we should try to bring secant square x. Now this we can write as 2 integral 0 to pi by 4 secant square x tan x dx minus 2 times integral 0 to pi by 4 tan x dx. Here, if we differentiate tan x, secant square x dx is coming, tan x is y, we have to check the limit. When x is 0, x is 0, tan 0 is 0, y is 0, and when x is pi by 4, y is equal to tan 45 degrees 1, 2 times integral 0 to 1 tan x is y, secant square x dx is dy, minus 2 times, if we integrate tan x, what will come? Log of secant x. To pi by 4. So 2 is y square by 2, 0 to 1 minus 2 times log of secant pi by 4 minus log of secant 0. 2 will get cancelled, we'll get 1 minus 2 times secant cos 45 is 1 by root 2, cos 45 is 1 by root 2, so secant 45 is root 2, so log root 2 minus secant 0 is cos 0 is 1, secant 0 is also 1, so log 1, so log 1 is 0, so this becomes now 1 minus log root 2 square, so it will become 2. So this will become 1 minus log 2 is equal to RHS. So take the left hand side, 0 to 1 sine inverse x dx is there. So we cannot integrate sine inverse 1 directly, we have tried to 1 into sine inverse x. So integrate 1, x will come into second function sine inverse x 0 to 1 minus integral of integrated function x into differentiation of sine inverse x 1 by square root of 1 minus x square dx. If we differentiate 1 minus x square, minus 2x is coming. So, okay, we'll write that again. Put 1 into sine inverse 1 is pi by 2. You put 0, 0 will come. Then minus integral 0 to 1 square root of 1 minus x square dx x. If we differentiate 1 minus x square, minus 2x will come. So I'll write minus 2x. So that means make plus. So 1 by 2 here. Now let 1 minus x square is y. This gives what? Minus 2x dx becomes dy. When x is 0, 0, y is 1. When x is 1, y is 0. Therefore 1 becomes pi by 2 plus half times integral x 0 to 1, y 1 to 0. Then this will be square root of y. This will become dy. So pi 2 plus half minus half times integral 0 to 1 y power minus half dy. So pi by 2 minus half times. If we integrate y power minus half will come y power minus half plus 1, y power half by half, y power half by half, 0 to 1. So these two get cancelled. So pi by 2 minus, you put upper limit 1, lower limit means 0. So this is equal to RHS. So this is the answer.